this video, we're going to look at how to summarize different categorical variables using R. Specifically, we're going to read in data from the BRFSS and learn how to create both frequency tables and bar plots for different categorical variables. So before we get started, located on Canvas in Module 5.3 are two files that you'll need. The first file is a file with the R code that you can find here, and the second file is a file with a reduced version of the BRFSS or the BRIFIS data set. So the first thing we're going to do is open the file that has the R code. So in RStudio, we can click on File, Open File, and then you can navigate to where on your computer that file is located. And you should see a file that looks something like this. This file is broken into three different sections. In the first section of the file, we're going to see how to read in and edit the data set. In the second set, we're going to create frequency tables, and then the last part, we'll create a bar graph. So the first thing we're going to do is read in the BRFSS data set. There are two different ways that you could do this. You could click on the File, Import Data Set, and use the method that we saw in the first R video for this course. Or we could set our working directory and then read in the data set that way. So let's first see how to set our working directory. Remember that your working directory is the folder on your computer where R will work out of. So the first thing we want to do is find that folder. To do that, in the bottom right-hand window, you can click on Files, and then click on the three horizontal dots. This will open up a file navigator on your computer. Now, one thing to note is this is only going to show the folders. It's not going to show any of the individual files. So from here, you want to navigate to the place on your computer where the data set is located. Again, keeping in mind that the actual file won't show just the folders. Once you click Open, you should see the file name here. So we're looking for the BRFSS reduced data set. Next, to set your working directory, you can click on More, Set as Working Directory, and you'll notice a line of code is populated down here. If we copy that line of code, we can paste that into the file, and now we have that command ready for in the future, and we don't have to go through those steps. We would just need to highlight it and click Run. And again, the working directory is set. So the next thing we're going to do is read in the data set. We can read in the data set using the read.csv function. If you want to read more about the read.csv function, you can run this line of code. It will open up the Help tab with some information about this function. So to read in the data, we need to give the data set a name. So I'm going to call it the BRFSS data. I'm going to set it equal to, and remember that the left pointing arrow in R means equal to, and then I'm going to use the read.csv function. To use this function, inside the parentheses, I'm going to give it the name of the file in quotations, comma, header equals true. So if we run this file, or this line of code, notice that the BRFSS data now appears up here. It has 389,826 observations and 18 variables. So again, this is a reduced version of the BRFSS. It does not contain all of the variables that that data set contains. If we wanted to look at just the beginning of the data set, we could use the head function. And so notice down here in the console, we have the first 6 rows of the data set printed for all 18 variables. Now, one thing to notice here, if we look at the different variable names, notice that many of them have an X in front of them. The reason for that is in the data set, some of the variable names start with an underscore. R will not allow data or variable names to start with an underscore, so it places an X in front of them. So for example, if we look at the BRFSS codebook, and we look at page 2 of the codebook, we can see we have the SAS variable name underscore state. So R automatically places an X in front of that. So on your computer, to read in the data set, you don't need to make any changes to this code. You should be able to run as is. The only change you may need to make is if you download the data set multiple times, it may change the file name. So you just want to make sure this file name matches the file name that you have on your computer. Next, what we're going to do is we're going to subset the data set to only include data from a specific state. So in the videos, I'm going to work with the state of Kentucky. For your assignments, you'll want to subset the data for the state that your group was assigned. So in order to subset the data, we are going to use the state variable. So again, if we look at the codebook, the state variable, what it represents is what state that particular observation came from. And so notice the state of Kentucky is represented by a 21. So to create a Kentucky data set, I first give the new data set a name. So here I'm going to name it KY_data. I'm going to set it equal to, and then I'm going to use the subset function. Inside the subset function, I'm going to place the full data set and then the condition I want to subset by. So here I want a data set that only contains observations for which the state variable is equal to 21. And notice there are two equal signs here. So we can run this code. And we can see that now we have a much smaller data set with 2,869 observations and 18 variables. So we have a data set that only contains data for the state of Kentucky. For your assignment, you'll want to do something very similar. The only changes that you'll need to make is you won't want to call your data Kentucky data. You'll want to use the abbreviation for your state, and you'll change that abbreviation here and here. And then you don't want to use the number 21, you want to use the number for your particular state. So for example, again, if we look at page 2 of the code book, if we look here at the state of Florida, notice Florida is represented by a 12. So here I could change this to FL and FL, and then the 21 would be changed to a 12. So that's how you can create a data set that only contains data for your state. Now, depending on your topic, you may be interested in only males or only females. So for example, if you are interested in breast and cervical cancer, you may want to reduce your data set to only have females in it. We can do that as well. So here, to make a data set that only contains males, I'm going to call it Kentucky_M_data. And again, I'm going to use the subset function, read in the full data set, and then I'm going to give it two conditions. I'm going to have the X state variable equal to 21 for Kentucky, and then we have a second variable which is called the sex var variable. So again, let's go and look at our codebook. Now the codebook is pretty long, it's 161 pages, so sometimes finding different variables can be difficult. One thing that you can do is always use your search function, and you could search for the variable name. So we see the first instance comes on page 18, and we can see that the sex var variable tells us the respondent's sex, and it's 1 for male and 2 for female. So here, to make a data set comprised only of males, we have sex var, 2 equal signs, and 1. To have a data set comprised only of females, we do the exact same thing, except we place a 2. So if you have a topic that needs to be subsetted so that you only have males or only have females in your data set, you will also want to run these lines of code. You'll only need to include one of them in your file depending on which way you're subsetting. Now, if your group's topic is flu and pneumonia vaccines, then you want to include both males and females, so you'll only use the first line. But in either case, the only pieces you're changing are going to be the number that corresponds to the state, and then the abbreviation that you use. For those of you that do subset to either include only males or only females, do make sure that you include both of these steps, because later on you'll want to come back. There is one worksheet that requires everyone to look at the full data set, but that will be a couple weeks from now. Now the last thing we're going to want to do is let's save these new data sets so I have them to use later so I don't have to repeat this process. We can use the write.table function to do that. So to use the write.table function, I put in the data set name that I want to save. So in this case, I'm going to save the full Kentucky data set. I give it a file name. So here we've got Kentucky_data, and I'm going to make a CSV, so I'm going to call it .csv. And then the other pieces here, these help R know how to create the file. So let's run this. You'll notice nothing appears up here, but if I go over to the files, I now have a Kentucky data set. So if you're following along for your state, you now have a much smaller version of the BRFSS that only contains data for your state that you can use for the rest of the course. So to just kind of recap what you'll want to do in these pieces here, you'll want to set your working directory, read in that CSV that's located on Canvas. Next, you'll subset your data. For each of these, you would include the state that you're interested in, but then also, depending on your topic, you may only be interested in males or females. And then you want to save that new data set to your computer as a .csv. All right, the next thing we're going to look at is how to create a frequency table in R. So we're going to look at the education variable. So before we see how to create the frequency table, let's look at the education variable in the codebook. The education variable is located on page 145. And we can see this variable here. So this looks at the highest level of education completed. So a value 1 represents did not graduate high school. A value 2 means they graduated high school. 3, they attended college or technical school. 4, they graduated from college or technical school. And then a 9 represents don't know, not sure, or missing. All right, so the first thing I'm going to do is if we were to look at the education variable in the data set, and let's actually do that. We can do that by if we just click over here, we can view the full data set. Notice that currently the education variable takes a lot of numeric values. Well, it would be really nice if we had those same labels from the codebook, and we can do that. So what we're going to do is we write the name of our data set, $, and then I've got the name of the variable _new. What this is going to do is this is going to create a new education variable to add to my data set. And this new one, instead of having the numbers, are going to have some labels that are more meaningful. So here we're going to use the with function. So we use the name of the original data set. Then we have factor. That's not a word that you're going to change. The name of the education variable. Levels are going to be the different numbers we see in the codebook. And then labels are going to be the labels that we want to give that particular variable. And so notice these are going to be in the same order as the codebook. So if I bring the codebook over, for example, again, go down to page 145. So notice that a value 1 represents did not graduate high school. So here I've used an abbreviated version. I've said less than high school. 2 was graduated high school. So I've used an abbreviated thing here where I just said high school. And notice that I have these in between quotation marks, and they're given in the same order as the numbers. So let's run these lines of code. So notice that the Kentucky data set now has 19 variables. We've added a new variable to it. And again, if I click on the Kentucky data set, let me click over here and bring it back up. If we go all the way to the scroll all the way to the right, notice there is a new education variable. And instead of having the numbers, it now has some meaningful labels. Next, we can create our relative frequency table. R has a lot of functions that are pre-built into it, but there's also some extra ones that we can add that can be very useful. And so one of these is one that's called the tidyverse. So in order to use the tidyverse, we need to pull it forward. So I'm first going to show you how to do that. This step that I'm getting ready to show you, you only have to do once. So if you click on Tools, Install Packages, and we're going to search for tidyverse, and you click Install, it's going to go through. You're going to see some messaging here. Okay, so once that's finished, you then run this line of code. You'll see again some messaging. That's perfectly fine. And now we're ready to go. So to create the frequency table, I have some lines of code here. Let's first run it. Okay. And we can see we get a frequency table down here. In the first column, we have the variable name, and we have the different levels that it takes. In the second column, we get the frequency for each of those, and then we get the relative frequency or the proportion. So for example, in this particular sample, there were 278 people with less than high school, which was about 9.7% of the sample. For those that graduated high school, there were 864, and that accounted for about 30.1% of the sample. And so that's how we can get our relative frequency table. Now for yours, the only things you'll need to change here is instead of the Kentucky data set, you would give your data set for your state, change the name of the variable, and that's it. We only change these two pieces. Last thing we're going to do here is create a bar graph. So again, I'm going to run the code here. You get a warning message, that's okay. And here is our bar plot. You can see here we have those labels here along the x-axis. We have relative frequency along the y-axis. We have our title. So looking at the code, again, the only things you'll change is you'll have data is equal to the data for your state. Inside the second line, the only thing you'll change here is the name of the variable. You can also change the color to have different colors. And then in the last line, you'll want to add in a title as well as some labels for your x and y axis that make sense for a particular variable. And I'll show you how to do that here very shortly. So that's how you can make frequency tables and bar graphs using R. So now what I'd like to do in the video is I'd like to transition and help you work through your first assignment. Or sorry, I shouldn't say your first assignment, but your first assignment using R to look at the BRFSS. So again, let's go back to Canvas. So if we click on Canvas, we're going to look at this Summarize Categorical Variables software assignment. I won't always go into such detail in the videos for the assignments, and the other ones I'll just show you the code and what it is you need to change, but for this first one I do want to walk through the different steps. So here we have the assignment, so let's first start by looking at it together. So step one is you're going to create an R script, and in that R script you're going to write in the code, read in the data set, and create that smaller data set. So this is the exact same thing that we just did for the Kentucky data set. Then you're going to create and interpret relative frequency tables and bar graphs, summarizing 3 different categorical variables. Your first variable you'll want to choose from this list. So you'll want to identify what the topic for your group is. So for example, if your group chose to work with breast and cervical cancer screenings, you'll want to choose one of these 2 variables to look at. If your group chose to look at flu and pneumonia vaccines, you'll want to look at one of these two variables, and it has the corresponding page number for the codebook. And then you'll also want to choose a demographic variable. Notice I've already done the education one. You're welcome to choose that one or other ones. I would recommend, you have to do all of this work by yourself, but it may be beneficial to talk with your group members and say, hey, I'm going to work with these two. Which two are you working with? And some overlap is good. That way you can compare graphs, but also making sure you have a variety of variables to look at. So again, you can ask your group members what variables are you going to look at, so you make sure everyone looks at different variables, but you cannot work on the assignment together. So again, one variable from the list up here, and then two different demographic variables. So you'll want to first write the code for these, and I'm going to show you how to do that in just a second. And then you're going to use that output that you get to actually place these in a document. And you'll go ahead and start interpreting these. The reason that you'll do this is then later on you'll be able to use this information for your reports. And then also what I have here on Canvas is an R script that you can use to fill in for your assignment. So you'll want to download this file. All right, so let's go back to RStudio. So the first thing I'm going to do is open up that R script that we just saw the file for. So I'm going to go to File, Open File, and this one is called the Module 5.3 R script. Open. And you'll notice that it's a file and it has some comments in it. So you're going to fill in these different places for the comments. So notice the first section here is read in and edit data. So in this section, this is where you're going to read in that file, and this should say the BRFSS reduced file. We're not reading in the full one. So in this space, this is where you're going to place the code to read in that file and to subset it. So what you could do is go back to the file that we just saw from the video. This section that's read in and edit the data, you can copy it and paste that into here. And now you'll go through and make the different edits. So the first thing you'll want to do is change this. So that's where the folder containing the reduced BRFSS is located on your computer. Read in the data set. As long as the file name didn't change, you don't need to make any changes to this line of code. If you want to look at the beginning of the data set, you can read this line. No changes needed. Next, you'll want to subset the data for your state. So this is where you'll make 3 changes. You'll change the abbreviation to match the abbreviation for your state here, and you'll change the number to match the number for your state. And again, these come from page 2 of the codebook. And then if you want to look at that data set, the smaller one, you'll change that to be the abbreviation for your state. Then, depending on your topic, you may be interested in males or females. So if we go back to the directions here, there are 3 different topics. If your group chose to look at breast and cervical cancer screenings, you'll want to reduce your data set to only be females. If you're looking at colorectal and prostate cancer screenings, you'll want to reduce your data set to only being males. And if your group is looking at flu and pneumonia vaccines, oops, didn't mean to highlight all that, you'll want to, you don't want to reduce based on sex. All right, so to reduce based on male or female, you will only need one of these lines. You won't need both of them. So if you're reducing to only include males, again, you'll change Kentucky to be the abbreviation for your state, and you'll change state to be your number. Only changes you need to make. And then last, to write the data set that we have here, you'll want to write to your computer the data set that you're going to use in the future. So for example, if you are working with flu and pneumonia vaccines, you will save the full data set. So you'll only need to change this to have your state's abbreviation. If you're working with the male data set, you would need to call in KY_M data, but instead of KY, it would be the abbreviation for your state. So you're only changing this to be equal to the data set you want to save, and then you'll want to choose an appropriate .csv name to go here as well. You don't need to change anything else. And so that'll be all of the code you need for this section. In the next section, you're going to create a relative frequency table and bar plot of the topic variable. So you'll want to come over to here and choose a topic variable to look at. So for example, let's say I wanted to look at this topic variable right here, the pneumonia vaccine one. The first thing I'm going to do is go over to our previous script from the video where we saw how to create a frequency table and bar graph. I'm actually going to copy both of these and I'm going to paste them right into this section. So then I can go through and make the changes that I need to make. Now here, we're going to create a frequency table. And just to remind myself, what I'm going to do is actually put in the variable name that I'm interested in. Now remember that R won't let us start a variable name with an underscore, even though it's that way in the code book. So I need to put an X in front of it. Right, so I'm going to go through and just make the changes that I need to make here. So I'm not going to work with the education variable. I'm going to work with the pneumonia vaccine variable. Next thing I need to do is give it some meaningful labels. So from the assignment, I can see that this variable is located on page 150 of the codebook. So I'm going to go over to my codebook to page 150. Here's the variable I'm interested in, and notice it takes the values 1, 2, and 9. 1 is a yes, 2 is a no, and 9 is a don't know or not sure or refused. So here, what I want to do is I'm going to create a new pneumonia vaccine variable. So I'm just going to put that name here. I'm still going to keep the underscore new because it's going to be a new one I'm making. I'm doing this with the Kentucky data, but again, you'll do this with whichever data set you're using. I'm going to paste the name of the pneumonia vaccine variable. And now the values or the levels that this variable takes, again, are 1, 2, and 9. So I'm just going to change the numbers to be 1, 2, and 9. I'll separate it by a comma. And then I want the labels to match what is in the code book. So in the code book, a 1 represents a yes, 2 represents a no, and 9 is a don't know, not sure, refused, or missing. So I'm in quotations. The first label that I'm going to have is yes, and then a comma, and then in quotations the second label, and then in quotations my third label, which I'm going to call unknown. And then I can delete the other ones. Be careful not to delete out your closing parentheses here. So I'm going to run this. I'm going to look at my data set, go all the way to the end, and I can see that these are NAs. But I do see some yeses and I see some unknowns. So just to check if that looks reasonable, I'm going to go over to my pneumonia vaccine variable in the data set, which is right here. And I can see that when there was a 2, I got a no. When there was an NA, I got an NA. So in R, an NA just means there was a missing value. So all of that looks good. Next, I'm going to call the library tidyverse. Now, again, you only have to do the step where you came up here and did the install one time. This library one, you need to run this each time you run a new, you're working in a new script. So just to be safe, we'll run it to make sure everything stayed. And now I need to make my changes down here. To get my frequency table, again, I'm working with the pneumonia vaccine, so I want to change the education one over to it, and that's the only thing I need to change here. And now I have my new frequency table. Last, I need to make my bar plot or my bar graph. Data set stays the same. I need to change it over from the education variable to the pneumonia vaccine variable. All of this stays the same. But let's say that I wanted a different color. Say I wanted this one in red. I need to change this, my title, to be something that's meaningful for this particular variable. So in this case, This is going to be for the pneumonia vaccine. And I don't want to just have pneumonia vaccine, so maybe I'll call this received pneumonia vaccine. Now in here, N is the total number of observations that are used to make the particular plot. Well, you'll notice that there was a whole bunch of missing values, and we see those by the NAs for this particular variable. So to get what this value should be for this particular plot, what we want to do is add up the frequencies that weren't missing from the frequency table. And here's where it's handy to use R just as a calculator. So down here I'm going to do 611 plus 235 plus 112. And we can see that there are 958 observations represented in this particular plot. The y-axis is still going to be relative frequency, but here on the bottom is really whether or not they have received the vaccine. So notice now if I run this, I get my new bar plot. Now, one thing that we might not like with this bar plot is notice that there is a really high number of NAs. Those are missing values. Missing values may or may not have meaning depending on how they're calculated. So often for the BRFSS, we actually want to remove those missing values and then document that we remove them. And so one way that we can do that is actually by using that subset function that we saw earlier. So if you happen to make a bar plot and you see a lot of NAs or you just have an NA bar, I would recommend removing it. And so now I'm going to show you how to do that. So here, when we create a bar plot, if that occurs, you can actually change this right here in the data set. So we'll use the subset function, just like we did earlier when we created a data set. Get you an extra parenthesis there. And then what we're going to do is we're going to subset the Kentucky data set, but really we only want it when that pneumonia new vaccine is not equal to missing. And to do that, we do exclamation point is .NA, open and close parentheses, and then we put in the name of that variable. So now if we run this, notice that's now gone. Our bar plot looks much better. And now that N equal to 958 in the title makes more sense. So again, if this won't happen with all variables, but if you're a particular variable, you end up with a lot of missing values, do go ahead and remove that using this trick right here. All right, so now that we've went through and we've done this for one of our variables, let's go back to the assignment. Notice in the second part of the assignment, you're going to place everything into a document. So let's see how we can do that. So here, I'm just going to make myself a new Word document to work with. So here's a new Word document. And so let's say we're going to create our document and we want to have our first relative frequency table. And a bar plot. Okay. And let's give it the name of the variable that we're interested in. So for this particular one, we use that pneumonia vaccine variable. So I'm going to place its name right here. Now, to include the relative frequency table, relative frequency tables, the output that we get from R, they don't look very nice. So typically what we do is we actually create the table in Word and then just insert the values. So we can do that by doing insert table, and then we'll create a 4x3 table. Actually, let's do a 5x3 table. And then from here is where you would put in the different pieces and actually create the table. So for example, we would have yes, no, unknown. Again, we want to leave the missing values out, so we actually didn't need this bottom row. You'd have your 611, 235, 112. And then for the proportions, we would have the 0.21, 0.081, 0.04, and you might be noticing and say, wait a minute, those aren't going to add to 100% because of that, again, the large number of NAs which kind of get in our way here. So we could do a couple different things. We could recalculate these by hand, or what we could do is do the same trick that we did down here for the bar plots to remove those. So instead of having the Kentucky data set here, I could do that same trick with my subset and copy this and paste it here and get my new table. And I missed a little bit. Let me escape out of there. So now notice those NAs are removed and those proportions look a little bit nicer. So the counts didn't change, but we now get proportions that make more sense. 0.64, 0.25, and 0.12. Okay. Now, one thing we always want to double check is, do these add up to 100%? So we've got 64 plus 25 is 89, 91, 101. So what happened here was just due to rounding. This is going to add up to 100.01, but that's okay. We'll just want to make sure that we denote that in a footnote. So you can see kind of how I'm filling in this table. I'll let you finish. You would want to put the labels there. And then the other thing is you'll want to include a footnote. And you'll want to say there were 1,911 missing values. And then if you use any abbreviations, so for example, here we've got unknown. And this is where we'll go back to our code book. So really the 9 was all of these. So we could say the unknown represents and then we'd have the full piece from the code book. So again, we're just trying to be really transparent here and pull all of that information together. And then the last piece, to get your actual bar chart, you can do one of two things. You can right click on it and copy image, and then paste into the Word document. Oops. There we go. So you have that in the Word document. Alternatively, you could also, in the plot, go to Export, Save as Image, and save the image to your computer. All right. So for all of this, you're making very, very minor changes. If you do end up with those large values of NAs, I've given you some code here so you can see how I did that. So what I'm going to do so that you have this, I'm going to copy this. Oops, didn't go down far enough. Spell that correctly. I'm going to add that on to the Spring 24 example. And we'll call it Additional Example. So you have the code for that one as well, so you can get rid of those NAs. And I'll add in the minutes here so you know that after I make the video. So that'll be saved. And then again, just to finish out your other two relative frequencies and bar charts, if we go back and we look at the actual assignment. So for the assignment, you're going to pick two more of these demographic variables. If you're looking at the education one, you can copy the education one from earlier in the video. And then of course you'll want to pick one of the other ones. But the biggest trick that you would have to do is, again, to remove the NAs, and we've seen how to do that for the pneumonia variable already. You shouldn't come across anything else that needs to be tweaked or changed. If you do see something, let me know, and I'm happy to provide that code for you. So again, I just really want to emphasize here, I'm not expecting you to go out into Google and create code from scratch. Really what I would like you to be able to do with the information that's in this video is just edit the code that I'm giving you. And the main editing that you'll need to do in this case is really just replacing the names of the data sets, the names of the variables, and then the labels for the plot. Other than that, there really isn't anything else that you should be tweaking. You'll want to make sure the code stays pretty much in the same format that it is. If you end up messing up the code, you can always just go back to the code that I've provided, recopy it to kind of start over to edit. If at any point you have any questions, you get lost, you're getting errors, please use that discussion board, let me know, and I'm more than happy to help you.